Hi, this is John Whitaker for the Probability 1 graduate level class, and this is a sample lecture for what we will be doing for that class for the purposes of Distance Learning Committee to evaluate how the material is being sent to students. And today I will go ahead and get started with the very beginning of the class, and we'll start off with the definition. So a random experiment is an experiment whose outcomes are up to chance. So as an example, tossing a coin. I know every time we toss a coin, we're either going to get heads or tails, but on a particular toss, I don't know whether it is going to be heads or tails. And that's one example. And then you could roll a die. Again, here, when you roll a die, we're thinking of a six-sided die, maybe. And you know that the outcomes are going to be the numbers 1, 2, 3, 4, 5, or 6. But on a particular roll, you don't know which one of those 6 outcomes is going to occur. And third thing you can do is you can have something like an urn has 5 red balls and let's say 3 white balls. And a ball is selected. So that's another random experiment, because when we select a ball, we don't know whether we're going to get a red ball or a white ball, but we're going to get one of those two. An individual draw, we're not sure which we're going to get. Okay. Next thing I'd like to look at is the definition of a sample space. The sample space for a random experiment consists of all outcomes of the experiment. And is denoted by script S. So the sample space is a set. It's a collection of the outcomes. So as an example, we could have a coin is tossed, and then the sample space would be equal to heads or tails. So those are the only 2 possible outcomes you can get. And so here, you could have a die is rolled, and here the sample space would be consisting of the numbers 1, 2, 3, 4, 5, and 6. is a subset of the sample space. So, as an example, when we have the coin being tossed, then E equal to the set of just heads is an event. Another example is if the die is rolled, then we'll say the set F equal to 2, 4, and 6 is an event. In this last example, really F is the event that the die roll was even. Okay? So that's what we represent. And it is a subset, this F is, of our sample space, which were the numbers 1, 2, 3, 4, 5, and 6. So and what we mean by a subset, of course, is that it's a collection of items from the sample space. Another definition is two events, say A and B, are said to be mutually exclusive if A intersect B equals to the empty set. So for two events from a random experiment to be mutually exclusive, that means what they have in common, so that's what it means to be an intersection, is nothing. They don't have anything in common. So as an example, if you say a die is rolled, let A be the event, the number obtained is bigger than 4, and B be the event that the number is less than 3. Then A and B are mutually exclusive. We're now ready to define what a probability is. As a definition, a probability is a set function So I'm going to put this definition in quotes. It's not exactly right, but it'll be okay for our starting point. It's a set function whose domain is the collection of events from a sample. From a random experiment. Denoted by P that satisfies, I'm going to write down three things. One, 0 is less than P of an event, product of an event, which is less than or equal to 1. So this says that the answer in terms of the output value for this set function is a number that's in between 0 and 1. 2, the probability of the sample space is equal to 1. One more condition. Three, if E1, E2, and so on, it is a collection of events with En intersect Em being equal to the empty set, where N is different than M, then the probability of the union, as N runs from 1 to wherever it runs, of E N is equal to the sum, as N runs from 1 to whatever, of the probabilities of these events. So what this means is if you have this collection of events, sequence of events, that are, if you will, pairwise mutually exclusive, and that you union them up, by union you combine them all together and say, well, what's the probability of that? Well, it's the same thing as the addition of the probabilities of each events. So kind of pictorially for this, as an example, if I draw a box here, and this box represents our sample space. One way of looking at the probability is that, look, we're going to take the probability of something within this box, or the box itself, and we can think of the probability kind of as the cost. And so if you think of this as like a piece of land, and it's our whole sample space, and the probability or price of this piece of land is $1. Price of something happening, the probability of something happening is 1. And somebody can come along and say, well, what if I have just a group of things here that have no overlap? So this is like E1, E2, E3, E4. And someone says, well, I just want to buy these plots within the sample space. How much do I have to pay? And so since there's no overlapping, if you were to union them up, saying I want to buy these guys combined, the answer to how much you have to pay is the price of each part here, each circle. So we sum these up, and that's what this is saying. as an example, if you have a coin is tossed, we can define a probability by, okay, so the sample space when we toss a coin is heads, tails. And so the subsets of those, first of all, the empty set is a subset. And the probability of the empty set, it's going to turn out that that's always 0. And then you could have the probability of just getting the heads. And that I'm going to define to be equal to 3/4. 3. The probability of getting the tails, that's going to be defined to be 1/4. And then the last subset for our sample space here is the probability of the sample space itself, and that's going to be 1. And this does define probability. It's not the typical probability we think of when we flip a coin, because we think of flipping a fair coin, such that the probability of getting a heads is 1/2, and the probability of getting tails is 1/2. And that is a probability as well, but these others denoted as they are. But that's an example of a probability. Okay. What I want to talk about next is to look at the case where everything in the sample space is equally likely. So, as a definition, when the outcomes in the sample space are equally likely to occur, then the probability of an event is equal to the number of ways, so the number in the event over the number in the sample space. So let's do a quick example of that. So a die is rolled. Somebody might say, find the probability that the die roll is bigger than 4. Okay. So this is equal to the number of ways the die roll is bigger than 4 over the number in the sample space. Okay, so the number of ways that the die roll is bigger than 4, well, that means you got a 5 or a 6. And so with that being the case, there are 2 ways that the die roll is bigger than 4. And our sample space, if you remember, the collection of numbers 1 through 6, and so there's 6 in there, and so this can be reduced to 1/3. Okay, ladies and gentlemen, for the purposes of this sample lecture, I will conclude here. Thank you very much.